Hey everybody, I'm going to explain today a little bit about multiplying polynomials, and specifically I'm going to focus on how it's really just an application of the distributive property. Some people get confused when they're multiplying polynomials, especially when it's big ones, but they understand the distributive property, they don't see the connection between them. So first, really quick, let's go over the distributive property with some examples, and then we'll apply it to multiplying polynomials together. So distributive property, you say 3 times the quantity x plus 4 is 3x plus 12, or 3 times x plus 3 times 4. So there's that. It can also work if there is a variable in the front. So x times x plus 4 would be x times x, which is x squared, plus x times 4, which would be 4x. Okay. So a times b plus c will be a times b plus a times c. So hopefully that's pretty straightforward. If you want to review the distributive property a little more, go watch my other video. I'll put that link in the video description. So if you want, pause and go look at that. But now let's move on to multiplying polynomials together, which technically a monomial, one-term polynomial, it's technically a polynomial, but we're going to talk about this one, for instance, a binomial times a binomial. So the way you can think about this, the way kind of a mathematician sort of way of thinking of it, would be, for a second, let's pretend this right here is just one thing. I mean, it is one thing, but it's made up of two terms. But let's call it A. So if that whole thing was just an A, then it'd be normal distributive property, right? It'd be A times this plus A times this. Okay, so that would be A times x squared plus A times negative 5, minus 5A. Okay, so but A actually is x plus 7. So really, what that means is x plus 7 times x squared plus negative 5 times x plus 7. Okay, I just rewrote this, but where the a's are, I replaced it with x plus 7, because that's what we were using a to represent there. So hopefully this isn't getting too complicated, but basically I'm just showing you guys, you know what to do with this. It's that. So if you just pretend for a second this is an a, that's what you get, but then we'll change the a's back to x plus 7s. So, or in other words, this times that, and then this times that. The whole thing times each of those pieces. And then those are both just the distributive property again. So the way I wrote this, it's kind of funny, but basically I have x cubed plus 7x squared plus negative 5x minus 35. And then there are no like terms there, so the final answer would just be x cubed plus 7x squared minus 5x minus 35. Okay, and a little sloppy here, put equal signs on all the steps. So that is kind of a example to show you the idea. I'm going to go over it a little bit more, hopefully clarify it if that was too complicated for you. But basically just view the first polynomial as one thing, multiply it times all the terms in the second polynomial, and then go through and do the distributive property for each of those pieces, and bam, you're done. So it's just applying the distributive property multiple times. So to break it down a little bit, we're going to do that one more time, except with just A, B, C, D. So this is binomial times binomial. So what we did before, we did this times that and times that. So we get A plus B times C and A plus B times D. So that is purely just the distributive property. Okay, and then we did the distributive property again and said that's A times C plus B times C plus A times D plus B times D. Okay, and if you look at that carefully for a second and you think about it, you get each term in the first polynomial times each term in the second polynomial. So you get A times C and A times D. And you get B times C and you get B times D. So basically you just get one of each combination. So you get, so the result is these four terms, and it comes from each one here times each one here. So in other words, another way to think of it is if you just take the A and go to each of those, and then you take the B to each of those. That is probably the easier way to think of it instead of doing the distributive property multiple times and figuring it all out. You just know the end result is going to be each term here times each term here. And we'll do some examples with a bigger, let me do one right now really quick. A plus B times A plus B plus C. Okay, you could do, if you want, pause the video, do this on your own the way we did before with the distributive property. Those times A, those times B, those times C, and then distributive property for each of those steps. But what it's going to result in is A times A times B, A times C, and B times A, B times B, and B times C. Okay, and then A times A, you could put A squared if you want. And BA is the same as AB, so AB plus BA can combine those to be 2AB. That's it. So you could mess with the order if you want there, but that's the idea of how I think the best way to keep track of it all and multiply stuff out is. So don't do FOIL. If somebody told you that it works when you're doing a binomial times a binomial, but then when you get to bigger polynomials multiplying together, you get confused. So just learn the claw. So see how I was doing it here? It kind of like it's a claw, the thing's reaching over. You could think each one is kind of a claw reaching over, or you could think of, if you put it all together, it's like a lobster claw. So anyway, think of it as the claw. So I already did the example on the other page, but let's do one more really quick. 3x plus 4 times 5x plus 2. So the claw way, you don't have to think of each piece individually. You just go one at a time. Start with this one. You're going to go to each term over here. There's just 2 for this example, so we go this times that, this times that. 3x times 5x is 15x. 3x times 2 is 6. So I have that, and then 4 times 5x is 20x. 4 times 2 is 8. Those can add together. Sorry about that. And then those can add together. And that's what we get. 35x plus 14. So if you do it the claw way, you don't have to remember all the steps or try to figure it all out from the distributive property every time. You just say, start at the beginning, go to all the terms in the second polynomial, then go to the next one, and if there's more, just keep going so you finish all of them. Here's a bit of a longer example, but it's basically going to work exactly the same. I'm first going to start with this and multiply to each term over here. So x squared times x cubed is x to the 5th. Okay, sorry, I had a technical difficulty there. So I was just saying how you multiply the first term here times each of these terms. Now you're going to take the second term and multiply it times each of those terms. So first let me finish writing all the first ones. So we had x squared times x cubed is x to the 5th. X squared times negative 2x squared would be minus 2x to the 4th. X squared times 3x would be 3x cubed. X squared times negative 4 will be minus 4x squared. Okay, and then 7 times x cubed would be 7x cubed. 7 times negative 2x squared will be minus 14x squared. 7 times 3x would be 21x. And 7 times negative 4 will be minus 28. Okay, if you want, again, you could write that as plus negative 28 there, but same thing. So then I'll just add the like terms together. So x to the 5th, there's only one x to the 5th term here. So I'll just write x to the 5th. Then x to the fourth, there's also only one x to the fourth, minus 2x to the fourth. There are 2x cubed pieces. So 3x cubed plus 7x cubed, that's going to be 10x cubed. And then negative 4x squared and negative 14x squared will add to negative 28x squared. So if you're confused at all with the negatives, just change all the negatives to minus to plus negatives. So negative 4 and negative 14 is negative 28x squared. Then we've got just one x term, so 21x minus 28. And I'm just going to actually leave that as minus 28x squared. I think that looks a little better. So that will be the final answer for that. So it is a little bit of work, it takes a little bit longer, but all the steps are just the same as multiplying smaller polynomials. So we'll do a couple more examples just to get some more practice. For the next couple examples, if you want, you can pause the video and try it on your own, and then just skip ahead to the final answer and see if you got the right thing. I'm going to show all the work though. So first, we'll do example 6. So here we have a trinomial times a trinomial. It's going to be same exact thing as the other ones. So start with this times each term over here. Then we're going to go this one times each term over here. And then there's going to be one more step on this one. I'm going to do the negative 1 times each term. So hopefully the color coding shows up and you can see what I'm doing there. So, but if you just do it one at a time, it shouldn't be too bad. So maybe I should have done the numbers as I went, but I'll just do it right now. 3x squared times 7x squared is 21x to the fourth. 3x squared times negative 3x would be negative 9x cubed. 3x squared times 4 would be 12x squared. Okay, then the middle part I did in black. 2x times 7x squared is 14x cubed. 2x times negative 3x would be minus 6x squared. 2x times 4 will be 8x. And now the last part, which I did in purple, negative 1 times 7x squared will be minus 7x squared. Negative 1 times negative 3x will be positive 3x. And then negative 1 times 4 will be minus 4. Okay, so that's a lot, but we just need to add like terms now and we'll be done. So let's see. There's only one x to the fourth term. There are two x cubed terms here and here. So 14 minus 9, that makes 5x cubed when you put those together. Then we got 3x squared terms. So 12 minus 6 minus 7. So that total makes negative 1x squared. Or you could just put minus x squared if you want. I'll put minus 1x squared. And then we've got 2x to the first power terms. That's 8x plus 3x, which makes 11x. And then the only thing left is right here, the negative 4, minus 4. So all together, we've got 21x to the fourth plus 5x cubed minus x squared plus 11x minus 4. Okay, if you want, stop now. This video is getting a little bit long, but I'm going to do one example with multiple variables, because sometimes there's not just an x or x different powers involved. Sometimes there are x's and y's. Sometimes there are x's, y's, and z's. So this example I'm going to do has a's and b's mixed in here. So I'll just do this really quick without commenting, and then we'll be done. So 3a squared times 4a is 12a cubed. Here we go, minus 15. There you go. All right, thanks for watching the video.